The teaching at Vedantu was amazing. One aspect where Vedantu teaching differed from a normal offline coaching was the attention teachers gave to our doubts. No matter how many times we asked a doubt, the teachers would patiently clear the doubt every single time. And they made learning a very fantastic experience for us.
Hi guys, this is Saurav here and welcome to another session for Chemical Kinetics. This is lecture 8 and in this session we are going to talk about Arrhenius equation and what is the need for this equation. Okay, a warm welcome to everybody. Hello Preetam, hello Ashish, hello Jaideep, hello Ajay and hello Himanshu. So this session is the second part of chemical kinetics. The chemical kinetics topic is built up of two parts. One part is like identification of odd or integrated rate laws. The other part is what affects the rate. Okay, what affects the rate. So without much ado, let's start today's session. And before going forward, my message always to you guys is please do like, share and subscribe the channel so that the word spreads to the larger populace. What we have covered until now is this segment, which you can see, which is completely blue, and temperature dependence is something that we would be covering today. Collision theory, Arrhenius equation would be covered simultaneously, and after this would be completed, we would be taking problems. Okay, so very important aspect of this part is that the problem statement that is being given is generally revolves around the theoretical aspect of collision theory and Arrhenius equation. These days they are not giving very calculation intensive questions, so understanding of theory is very important. So please don't start questioning that sir problems कहाँ हैं. Problems आएंगे, पहले आप theory समझ लो, problems अपने आप हो जाएगा. ठीक है? Okay, so let's start today's session with what is meant by the temperature dependence of rate. Okay, what is meant by the temperature dependence of rate. Now what happens is when I try to write the rate equation for any reaction, let's say there's a reaction like this, A changes to B plus C, there's a reaction like this, and for this reaction I write the rate as rate is equal to some rate constant A to the power an order, A to the power n, where n represents an order. Now this is a simple mathematical relationship where you can see that the rate is influenced by K and is influenced by A and is influenced by n. Now assuming that it is the same reaction, which is being done at different conditions, what are the various things that we can do to modulate this rate, to affect this rate? क्या-क्या चीजें कर सकते हैं हम? Okay. So one thing that we can do is change the concentration. Can I do that? I can change the concentration. Things that we can do to change the rate is change the concentration. I can change the concentration and increase the rate or decrease the rate. Okay, so if A increases, the rate will also increase. Can I say that? When A increases, where A is nothing but the concentration, when concentration increases, rate will also increase. Also, can we say that if I change K by some method, I will change the value of rate? Okay. Shreyash, I know for n, when n is any positive value, other than 0, I change the value of A, the rate will also increase. Okay, it's understood. It's very much understood to everybody. Okay, very much understood to everybody. Now, if I change the temperature, I usually see that the rate changes. Okay, for example, you want to dissolve a particular substance. You generally do it in warm water, process will be faster. You want to do a reaction, and reactions में आप देखोगे कि कभी कभार room temperature condition reaction रहता है, कभी कभार they give higher temperature condition reaction. So when I take a higher temperature condition reaction, the reaction takes place at a faster rate. So my first question would be that temperature is affecting what thing which affects the rate. So is temperature affecting the concentration? Is temperature affecting the concentration? No. If I increase the temperature, concentration will never change. Let's say I take the reaction, initial concentration as 5 moles. I take 20 degrees Celsius, it will be 5 moles. I take 40 degrees Celsius, it will be still 5 moles. Okay, so concentration is not gonna change with the change in temperature. What changes with change in temperature is this value K, which is known as rate constant. The rate constant changes, and because of that, the rate changes. Okay, try to understand. The rate changes because the rate constant changes. So temperature dependence of rate is nothing but the dependence of rate constant on temperature. If rate constant is changing because of the influence of temperature, the rate will also change. Clear? Now, how do we know that temperature increase करने से rate increase ही करता है? Okay? How do we know that temperature, Jagjit's, but sir, PV equals to nRT, so PC is equal to nRT? Dude, how is that possible? How is that possible? How is that possible? Okay, this is not gas laws. आप temperature change करोगे तो concentration कैसे change कर जाएगा? It will never ever happen. Concentration is constant. When you change the temperature, the only variable that can change is pressure and volume. Maybe. Okay. Temperature change करने से concentration change नहीं करता है. ठीक है? Is that understood? Cool. So let's not get into so many words right now. Let's try to understand कि कहाँ से ये चीज़ आई. So लोगों ने पहले क्या किया कि they tried to study enzyme catalyzed reactions. Okay. So a lot of reactions are there in our body which takes place under the influence of certain enzymes. Okay, enzymes present रहते हैं तो reaction होता है. Okay, enzyme present रहते हैं तो reaction होता है. It is generally written as in written NCERT. Don't know if it has any exception at increasing temperature. I don't know what you're talking about, Preetham. So let's focus on this part, that in our body there are a lot of processes which are influenced by enzymes, like ऑक्सीजनेशन, डीऑक्सीजनेशन, जो वेन्स में जाकर डीऑक्सीजनेशन, वहाँ पे भी एंजाइम की ज़रूरत पड़ती है. ऑल दीज प्रोसेसेस आर studied under different temperatures. Now, when the temperature is increased, it was observed that the enzyme catalyzed reaction was taking place at a faster rate. Okay, enzyme catalyzed reaction was taking place at a faster rate upon changing the temperature. Now, it was also observed that आपने सिर्फ अगर 10 degrees increase किया temperature, you increase the temperature by only 10 degrees, the rate of the reaction was increasing by 2 to 3 times. So this is known as temperature coefficient, which is the ratio of the rate of reaction at a temperature T plus 10 degrees Celsius and temperature at T degree Celsius. यहाँ पे temperature को X ले लिया है तो इसको X रहते हैं. So the rate of reaction at T plus 10 degrees Celsius and rate of reaction at T degree Celsius, इन दोनों का अगर हम रेशियो लेते हैं, if it is taken as the ratio, then I would get the value as somewhere equal to 2 to 3. Okay, so it is written in the NCERT, the rate of reaction generally increasing in temperature. Is there any exception? No. There is no exception. Rate of reaction will always increase with increase in temperature. I will get to this a little later. Let's try and understand. This is an observation. So reaction quotient is an observation. ये जो चीज़ है ये observe की गई है. This is an observation. Behind this observation, there is a logic which is explained using something known as collision theory. Okay, so there's some, so ये जो observation हमारे पास आया, if I increase temperature, the rate is increasing, there's an observation, and to validate why is this happening, we take a theory known as collision theory. There's so many theories which explain why this happens. The most common and the simple one, and the one that is there for JEE, is collision theory. There are some other theories as well. We do not have to get to that. We have to only cover collision theory. In collision theory, the basic assumption that we take is that we take a bimolecular system. दो molecule collide कर रहे हैं और reaction हो रहा है. Okay? कोई भी reaction करने के लिए, for any reaction to take place, I have to perform collision between molecules. Unless and until molecules collide, they will not participate in a reaction. Okay? They will not participate in a reaction. Jaideep, Preetam Mandal, there is no exception. Please don't say that. Okay? There is science and there is a false statement that you're trying to give. Okay? So there is a science which is backed by experiments. So don't say that okay, there is an exception. So we take an assumption that the reaction is bimolecular and the particles are in the gaseous state. Okay? What would it look like? किस तरह का दिखेगा? It would look something like this, isn't it? It would look something like this, that the particles, you can see that the red colored particles are colliding with the blue colored particles. Okay? Red colored particles are colliding with blue colored particles. Now, can we say that how many collisions are taking place in 1 second? The number of collisions are huge. The number of collisions are approximately 10 raised to 30 collisions which are taking place per second. Okay? 10 raised to 30 collisions. That's huge number. Okay? We can't even count that number. So 10 raised to 30 collisions are taking place per second. Okay? Fine. 10 raised to 30 second. We can take the mean value. Chemistry अच्छी दोस्त है. देखो, एक्सेप्शंस का मतलब ये नहीं होता है कि ना चीज़ें नेचर में जो ऑब्जर्वेशंस होती हैं, chemical substances are like kids. Okay, chemical reactions are like kids. Every kid has a different thought process. So बहुत सारे बच्चे एक तरह का thought process रखते हैं. बहुत सारे बच्चे IIT JEE के लिए जाते हैं, कुछ एक बच्चे नहीं भी जाते हैं. Okay, so वो exception नहीं हो जाते हैं. That's their way of life. Okay, so collisions is to the power 30. Now can you tell me what is the amount of, what could be the approximate percentage of effective collision, successive collision or successful collision? If I talk about all collisions, are all collisions successful? The very important point that you need to know over here at at room temperature, the fraction of successful collisions is very small. Successive collision होता क्या है? Successful. What is a successful collision? Successful collision is that collision which will result in a reaction. Okay? Successful collision is that collision which will result in a reaction. So you first have to understand that what constitutes a successful collision. जितने भी collisions हो रहे हैं, सारे collisions successful नहीं हैं. All collisions are not successful. Only those collisions are successful which can lead to a reaction, and at room temperature such collisions are very few. Okay, इसीलिए प्रोडक्ट बहुत कम बनता है रूम टेम्परेचर पे. यू हैव टू इंक्रीज द टेम्परेचर सो एज टू फॉर्म ग्रेटर अमाउंट ऑफ प्रोडक्ट्स. सो मूविंग अहेड, व्हाट वी कैन सी इज there are two cars colliding with each other. You can see that there are two cars colliding with each other. Okay, what constitutes a successive collision? Okay, what constitutes a successive collision? What constitutes a successful collision, not successive. What constitutes a successful collision? तो successful collision के लिए मुझे दो चीज़ें चाहिए. For example, if two cars are colliding, this is what is happening at the molecular level as well. Okay, this is what happens at the molecular level. दो molecules एक दूसरे के साथ exactly इसी तरह से collide करते हैं. Okay, they just try to rupture the bonds which are already present so as to reorient themselves and form a bond. So what constitutes a successful collision is optimum energy and proper orientation. These two things are very vital. These two things are very vital. Okay, let's not work on the heat part. Reactions which are very fast have more successful collisions. Yes, correct. When reactions are very fast, they have more successful collisions that are taking place at a particular temperature compared to a slow reaction. So अगर एक reaction हो रहा है, what would constitute a successful collision is optimum energy and proper orientation. Okay, this is a head-on collision. Obviously this is a head-on collision, आपने physics में पढ़ा होगा. Let's try to look into a particular scenario. Okay, इसको बहुत simple example से समझते हैं. So I am taking a path. एक road है. On this road there is a car. Okay, this is the best representation of a car that I can draw. There's a car. It more looks like a spaceship with wheels. So there are two cars at the two ends of this road. Now this car is moving in this direction at a speed of, let's say, 50 km per hour, or let's pick up value 100 km per hour, and this is moving in this direction. This is moving in this direction with also 100 km per hour. Okay, so you can see that this car is moving in this direction at a speed of 100 km per hour. This car is moving in the same direction at a speed of 100 km per hour. Okay, now what is happening? What is happening is that both the cars are moving in the same direction, and point is, do their energies are optimum? They have very high energies. They have very, very high energies. But what is missing over here is energy is, can I say, good, but orientation is bad. Okay, energy is good, orientation is bad. Will any collision take place? Will it cause any collision? Obviously not. Okay, let's take another scenario. There's a car moving on this side of the road. There's a car which is present on this side of the road. This is moving at a speed of 100 km per hour, and this is moving at a speed of about 200 km per hour. Both are moving with very, very high velocities. Okay, both are moving with very, very high velocities. They're moving in a straight line, but one, it's like on an expressway, one car is driving in one direction, the other person is driving on the other direction. Okay, so will they collide with each other? In this case, will they collide with each other? In this case, can I say that the energy is good, but the orientation is again bad? Okay, there is not proper orientation. ठीक है, कोई collision नहीं होगा यहाँ पे. They are moving in straight lines. Okay, orientation is improper. Next, this car is moving 5 km per hour. There's another car which is moving with 2 km per hour. Okay, Himanshu, think logically. Okay, fuel of first car is consumed. यार थोड़ा तो मतलब लॉजिक में रह के बात करो. मतलब हम we are considering ideal situations. When we are talking of ideal situations, things are moving in the straight line path without having to undergo any deviation. Newton's laws follow कर रहे हैं. ठीक है. So in this case, collision will take place. Orientation is very good. Orientation बहुत सही है. But what about the energy? Energy is bad. Okay, energy is bad. Clear? So 5 kilometer per hour, 2 kilometer per, they will collide with a very like low energy and not perform any fruitful collision. Yes, Shreyash, they would not perform any fruitful collision. We can take the fourth case where there is a car which is moving in this direction at a speed of, let's say, 70 kilometer per hour, and there's a car over here which is moving in this direction with a speed of, let's say, 100 kilometer per hour. In this case, is good orientation is also good. Okay, the last one will cause instant collision, instant death हो जाएगा जो भी बैठा हुआ है. So if there is a fruitful collision, the fruitful collision will be this one. So of all these scenarios, ये scenario work नहीं करेगा, ये work नहीं करेगा, ये work नहीं करेगा. The only scenario that will work is this. Effective collision is this. So what does this tell us? When the molecules are moving in random manner within a gaseous system, it is a very low probability that the two molecules will be moving in a straight line in front of each other. They will always be moving in random directions, and because of that the number of effective collisions, okay, number of effective collisions will be very less. So the chances that two molecules are moving towards each other like these two cars is very less. Okay, is that clear? Is that understood? That what is the meaning of optimum energy and proper orientation? Now optimum energy and proper orientation तो मुझे मालूम है head on होना चाहिए. Okay, proper orientation should be head on, but what is the value of optimum energy we really don't know. Optimum energy will vary from reaction to reaction. Okay, optimum energy will vary from reaction to reaction. Now what is the role of temperature? What is the role of temperature? Temperature क्या करता है? इसको समझने के लिए we will take an example, a very vivid example, a very real life example. We'll take an example where we consider a classroom of 100 students who have just moved in 11th standard. You consider yourself when you had moved in 11th standard. Okay, you consider yourself when you had moved in 11th standard. Okay, so when you moved in 11th standard, what is the scenario? So you move in 11th standard with a lot of hopes, lot of aspirations कि भाई मुझे JEE qualify कर. Let's say all these students are studying science and they all have this interest of qualifying JEE. So can you tell me what would be the number of students who are very good in the class who could qualify JEE on the same day they move in 11th standard? It could be just one. So ये जो हमारे 100 students हैं, out of these 100 students, can I say that class में एक बच्चा तो होगा who is like marvelous, who is like a prodigy, and probably he can qualify JEE maybe on that very day? Okay, हो सकता है. Very few. Can I say so? One student can qualify JEE. Okay, one student can qualify JEE. What you do, guys, is that you put 2 years of hard work, and after 2 years of hard work you find that 30 students have qualified. 30 students qualify JEE. This is after 2 years. This is after 2 years. So 30 students qualify JEE after their self study of 2 years. ठीक है? Clear? Very simple scenario. तो ये एक जो बंदा है, ये 11th में जैसे ही एंटर किया, he can qualify JEE अगर उसको उस दिन आपने पेपर दे दिया. And 30 students, like all these 100 students are putting effort, out of which 30 students qualify at the end of 2 years. Okay, 30 students qualify at the end of 2 years. Now consider ये 30 students ने मेहनत की थी without a teacher. These 30 students were without good teacher. एक अच्छा टीचर उनको नहीं था, फिर भी 30 स्टूडेंट्स क्वालिफाई कर गए. लेट्स से देयर वाज नॉट अ वेरी गुड टीचर, नॉट प्रॉपर मेंटरशिप, सो किसी तरह लड़ते मरते दे क्वालिफाइड JEE 30 students without good teacher. Okay, suppose there is a good teacher. Good teacher comes. If there would had been good teacher, okay, so this number, don't you think that this number would had increased from 30 to maybe 50, maybe 60 क्वालिफाई कर जाते. अगर आपको अच्छा टीचर मिलता तो 60 क्वालिफाई कर जाते. Isn't it? Isn't it? So if, बताइए, if there would had been good teachers to teach you, don't you think that these 100 students would had, out of these 100 students, rather than 30, maybe like 60-65 students would have qualified. तो 60 to 65 क्वालिफाई कर गए. Isn't it? हो सकता है. So what is this good teacher doing? What is this good teacher doing? The good teacher, does he leak the question paper? बताइए. अरे शिव, आप क्या बोलते हो? बंदे पे डिपेंड करेगा. अरे 30 से ज्यादा तो होंगे. 30 विदाउट एनी इनपुट के क्वालिफाई कर रहे हैं. 30 आर क्वालिफाइंग विदाउट एनी इनपुट्स. ऑब्वियसली दिस नंबर वुड बी मोर देन 30. मैं 60-65 ले रहा हूं, इज 30 से ज्यादा तो होने चाहिए. So what would a good teacher do? Okay, I think you have understood the example. So I'm just gonna take this scenario, that what is the good teacher doing? And what he is not doing. Okay, what is the good teacher doing? The good teacher is bringing confidence, builds confidence. Okay, what is the good teacher doing? He imparts proper knowledge. He imparts proper knowledge. Okay, प्रॉपर नॉलेज का मतलब जो पढ़ाना है वही पढ़ाया. नहीं, ऐसा नहीं किया कि they just spent the time in the classroom. Okay, a good teacher gives you proper knowledge, proper direction, can I say this? The good teacher gives you proper direction, motivation हो गया, builds confidence, imparts proper knowledge, and what he has done, overall improvement. Can I say this? When all these three things happen to a student, then the student has a overall improvement in his personality. Maybe like the results will also improve, isn't it? What is the teacher not doing? What is the good teacher not doing? Okay, what is the good teacher not doing? So good teacher is not taking shortcuts. The good teacher is not taking shortcuts, not giving I would say question paper. Okay, अच्छे टीचर आपको क्वेश्चन पेपर नहीं करेंगे, वो आपको डिमोटिवेट नहीं करेंगे. not demotivating, and most importantly, is the good teacher decreasing the difficulty level of examination? Is the good teacher decreasing the difficulty level of examination? Think carefully and answer this question. Is the good teacher decreasing the difficulty level of examination? Not decreasing difficulty level of, let's say, IIT JEE. So JEE का level जो है, JEE level remains the same. JEE remains it's still very difficult. What the teacher has done is give you more confidence to qualify it. JEE level remains the same. The teacher only gives you enough skills or inputs to qualify it. Difficulty level change नहीं करेगा. Difficulty level, exactly, your perception of the difficulty level will change because you might have these three things. Okay? Your perception of the difficulty level will change because you might have these three things. Clear? Now, is this understood? Is this understood? So temperature का जो रोल होता है ना, वो एक टीचर का रोल होता है. Okay, the role of temperature is that of a teacher. The role of temperature is that of a teacher. Your teacher is not giving you shortcuts, so temperature is also not taking shortcuts. Temperature is gonna increase energy uniformly. It's not giving you the question paper, that means it is not reducing the challenge. Temperature will not affect the challenge. Challenge को affect कौन करता है? What will affect the challenge is a catalyst. A positive catalyst will decrease the challenge. A negative catalyst will increase the challenge. So a positive catalyst is like, आपने examination qualify नहीं किया, आप अपने डैड के पास गए, बोले कि मेरे को तो कॉलेज जाना है, तो उन्होंने क्या किया कि आपकी एडमिशन किसी कॉलेज में करवा दी, बस आपको वहां पे अपना नाम लिखना पड़ा. ओके, सो लेट्स अंडरस्टैंड इट इन अ ग्राफिकल वे. So let's understand this in a very, very graphical way. This is a plot of your, let's say, energy versus time. This is a plot of energy versus time that I'm plotting for these 100 students who are present in the class. Obviously, there is some student who has, I would say, इसको मैं potential बोल देता हूँ, potential, or I can say capability. Potential or capability. So this is a plot of potential or capability versus time. This is like when you are in 11th, और ये जो पॉइंट है ये आपका कॉलेज का पॉइंट हो गया. इस पॉइंट पे जाके आप खुश रहते हो. ओके, दिस इज द पॉइंट वेयर यू आर इन द कॉलेज. When you are in 11th standard, you have come with some potential. ऐसा नहीं है कि आप में कुछ potential नहीं है, आप में कोई बात नहीं है. You all are gifted in some or the other way. So 11th, when you move in 11th, you have this potential. Okay? You have in 11th standard, you have this amount of potential. It is also possible that your friend has this amount of potential. So this is a student A and this is a student B. And these are their two respective potentials or capabilities when they move in 11th standard. आपको क्या, आपको यहाँ पे जाना है इस जगह पे. This is, let's say, IIT This is IIT. So you have to give an examination. आपको IIT में जाना है तो आपको एक examination देना पड़ेगा. And that examination is the JEE examination. That is JEE Advanced. This is your JEE Advanced. और JEE Advanced को क्वालिफाई करने के लिए आपकी पोटेंशियल इतनी होनी चाहिए. Your capability should be this much. Okay? To qualify JEE Advanced, this should be your capability. So you have to put a lot of efforts to reach here, qualify the examination, only then you can come over here. This student also has to put a lot of efforts to come over here, and then only he can reach over here. Isn't it? So both these students have to put some amount of effort to cross this difficulty level. The extra amount of effort that the student B is putting is known as the extent to which he is activated. Okay? The extent to which he is activated. Similarly, so this I can call activation for B, and this I can call activation for A. Clear? So ये जो difficulty level है, एक टीचर क्लास में आने पे ये डिफिकल्टी लेवल कम नहीं होती है. Try and understand. When a teacher walks in a class, a good teacher teaches you for 2 years, they do not decrease this difficulty level. They cannot change your raw potential. They can only enable you to have this or not have this. इतना आपको चाहिए, आप जैसे स्टूडेंट हो, इतना आपको चाहिए so that you go through this and come over here. The good teacher might enable you to have this. A bad teacher would not enable you to have this. That's it. Okay? So a good teacher is only enabling you to get this value. He is not even reducing this value. आपको जितनी effort करनी वो आपको करनी है. The teacher is not affecting this thing. Okay? So the teacher is not affecting the difficulty level of the examination or the effort that you need to put. He is only putting you in a proper direction and giving you proper advice and mentorship. Very good. So if I convert this on for a reaction, then this will become energy. This will become time. Happiness is products. This will be reactant 1. This will be reactant 2. This overall difficulty is known as ETH, or it is known as threshold energy. Threshold energy. EA is known as activation energy. Is known as activation energy. So this is known as a reaction coordinate, and you can see that how a simple scenario of a classroom and the number of students qualifying and the role of a teacher can be replicated to understand what happens during the course of a reaction. Reactant comes with a certain potential energy. It needs some extra energy to cross the threshold energy barrier. Role of a teacher is fulfilled by temperature, which does not alter this, only enables the molecules to have proper orientation and proper energy. Okay, so proper motivation and proper inputs means, so you need more activation energy. Yeah, depending on where you are present, you need more activation energy or less activation energy. Okay, but why very few I can't tell you that. and answer that question of yours. I hope this is understood to you. So remember that never say that when you are looking at role of temperature, it will not alter ETH or EA. ठीक है? It will not alter threshold energy or activation energy. याद करके रखिएगा. ठीक है? Now catalyst का role क्या है? What is the role of a catalyst? Catalyst has the role of a parent. आपने examination qualify नहीं किया. You didn't qualify the examination. So what you did is that you went to your dad, told him that मेरे को college जाना है. So he provided you with an alternate pathway whose threshold energy is less. He provided you with an alternate pathway whose threshold energy is less. So when they provide you with an alternate pathway with threshold energy is less, that means they are putting up the role of a positive catalyst. Let's say people demotivated you. So what will happen? The chances of you qualifying the examination will further decrease. So demotivation, this is demotivation. और ये हो गया डोनेशन. डोनेशन पे एडमिशन हो गया तो आपकी कैटलिस्ट की का ओके. The top over here, when somebody is demotivating you and you are totally demotivated, the chances that you would qualify the examination is very less. वो कैटलिस्ट माउंटेन का हाइट कम कर देता है. We can, yeah, you can understand it that way. So catalyst is something which will reduce the height of the mountain. Okay? So with that idea in mind, let's try and understand that why temperature does this. What is the reason temperature does this? You must have read in gaseous state a particular concept or particular thing known as Maxwell Boltzmann distribution function. आपने पढ़ा होगा Maxwell Boltzmann distribution. Okay, you must have read Maxwell Boltzmann distribution. Now what Maxwell Boltzmann distribution does is identify the fraction of molecules with respect to the energy. Okay, it identifies or helps us plot the fraction of molecules which have a certain energy at a particular temperature. Okay, so if you look at the distribution of energies at a given temperature, you would find that when the temperature, you will get these plots. So यहाँ पे है fraction of molecules. Fraction of molecules. Earlier at a temperature T1, we were seeing that the number of molecules which have very high energy is very less. Isn't it? Very high energy is very less. It is the same scenario as our class without a good teacher. Without good teachers, this was being crossed by only 30 students. This is like the amount, this is like the potential that they need to have to qualify the examination. This was possessed by only 30 students. But when the teacher comes in, the overall class improves. Overall class improves. So सारे molecules की, so all students move in the right direction. So the potential of all the students increase. Now the fraction of students which now possess this potential will also increase. Similarly, when we have a gaseous system, earlier the number of molecules which had this amount of energy which is necessary to perform the reaction, the amount of energy which is necessary to perform the reaction is very less. Now when I increase the energy, the number of molecules which now have the required optimum amount of energy to perform the reaction increases, and because of it the reaction हमारा तेज हो जाता है. More collisions take place, and so reaction happens at a faster rate. So T1 is a lower temperature, T2 is a higher temperature. As we increase the temperature, the number of molecules which possess optimum energy increases. Okay, and this is what we infer from Maxwell Boltzmann distribution, and because of this, or because of this feature, temperature accelerates a reaction. Clear? So with this, I would end today's session. In the next session, we will look at the mathematical aspect of it. We'll take up Arrhenius equation, and we would try to learn that what does Arrhenius equation try to imply in a physical meaning. What is the physical meaning of Arrhenius equation? Okay. So with this, I take leave. Remember, next session would be on Friday. Please do join us because we will be discussing Arrhenius equation. Okay. Chaliye guys. Bye bye and have a lovely time.